Ever wondered how your phone, laptop, or TV screen actually works? It's all thanks to a fascinating material called liquid crystal, a state of matter that's not quite solid, not quite liquid, but something in between. In this video, we'll explore how LCDs use this unique material to create images and dive into different display technologies like Twisted Nematic, IPS, and Advanced FFS. Let's get started. A liquid crystal is a substance that can flow like a liquid but has some ordering like a solid. This special combination allows it to interact with light in amazing ways. In an LCD, these crystals are placed between two pieces of polarized glass. When we apply voltage, the orientation of the crystals changes, and that controls how light passes through. Let's break down exactly how an LCD works in 5 simple steps. Step 1. Polarized light. 2 polarizing filters are placed at 90 degrees. The first filter allows light in a specific direction. Normally, the second filter would block it, but this is where liquid crystals come in. Step 2. Liquid crystal behavior. In the off state, the liquid crystals are twisted, rotating the light's polarization so it can pass through both filters, creating a bright pixel. In the on state, voltage is applied, the crystals align straight and light is blocked, creating a dark pixel. Visual. Interactive comparison of on versus off states with polarizers and light path. Step 3. Brightness control. By controlling the voltage per pixel, we can create different shades, from black to white and everything in between. Step 4. Color filters. Each pixel is divided into subpixels, red, green, and blue. Varying the intensity of each subpixel gives us full-color images. Visual, RGB subpixels, lighting up in different intensities. Step 5. Addressing the pixels. Passive matrix, older method using a grid of conductors. Active matrix, TFT. Each pixel has its own transistor and capacitor for precise control. Sharper and faster displays. Now that you understand how LCDs work, let's look at 3 key LCD technologies you'll find in everyday screens. 1. Twisted Nematic, TN. Animation. LC molecules twisted 90 degrees. The TN panel uses a 90-degree twist in the crystals. It's simple and cheap to manufacture. Pros. Fast response time, low power. Cons. Poor viewing angles, weaker color accuracy. TN is great for gaming monitors where speed matters, but not ideal for media editing or accurate colors. 2. In-plane switching. IPS keeps liquid crystals aligned parallel to the screen. When voltage is applied, they rotate in plane, giving consistent light control. Benefits: excellent color reproduction, wide viewing angles. Great for creative work, phones, tablets, and TVS3. Advanced Fringe Field Switching, FFS, is an evolution of IPS with enhanced electric field distribution. Used in mobile devices, automotive displays, and digital signage. Advantages: better brightness. Wider viewing angles, lower power consumption. Faster response time. FFS is what makes your phone look amazing from any angle, even under sunlight. So here's a quick recap. Liquid crystals control light using voltage. LCDs need polarizers, color filters, and transistors to work. Technologies like TN, IPS, and FFS offer trade-offs between cost, color, and performance. Choosing the right screen depends on what matters most to you: speed, accuracy, or visibility. Now that you know how LCDs work and the differences between TN, IPS, and FFS, which one do you prefer? Let us know in the comments. If you learned something new today, hit like, subscribe, and click the bell icon so you don't miss out on more tech explainers and electronics tutorials.